Okay, yesterday we completed about metallic conduction and electrolytic conduction. Now, next we are going to discuss about the electrolyte. Electrolyte. Electrolyte is nothing but simple. The substance whose aqueous solution allow the current, electric current throw into them. That is called electrolyte. The substance whose aqueous solution allow the passage of electric current and chemically decomposed are termed as electrolyte. Electrolytes. Example: AgNO3 silver nitrate, and next to MgCl2 magnesium chloride, and next to NaCl sodium chloride, copper sulfate, etc. And one more, non-electrolyte. Non-electrolytes is nothing but opposite of electrolytes. The substance whose aqueous solution, here is some. The substance whose aqueous solution water. Okay, water is not a electrolytic, or water is comes under, does the water is comes under electrolyte? Actually, water H2O, when it pure form, this is bad conductor of electricity. It will comes under non-electrolytes. But when it comes to water in with the mineral form, minerals is nothing but impurities. Impure form, that is electrolyte. That means pure form is nothing but distilled water. Distilled water is, we know already, you learned in 8th class physics. Distilled water is bad conductor of electricity. Because of in distilled water, it will not split as any ions. And impure water, that it can split as ions H plus and OH minus. Impure water, it is good conductor of, that will comes under electrolyte. But H2O in pure form, not that is not a electrolyte, non-electrolyte. That's why we will not take water as a electrolyte most of the situations. Okay, now write the non-electrolytes. The substance whose aqueous solution The substance whose aqueous solution do not conduct electric, do not conduct, do not possess or conduct. Okay. Do not conduct electric current. Electric current is called as is called non-electrolyte. Non-electrolyte. Now for this here example, solution of cane sugar. Solution of cane sugar. Glycerin, alcohol, etc. Here for example, this is electrolytic cell. In this electrolytic cell, if you take the HCl, in electrolytic cell we are taking HCl, hydrochloric acid. Okay. When it called as a acid, when it mix with water, that we can call as hydrochloric acid only. Without water, that we can call as a hydrochloric gas, hydrogen chloride gas. In gaseous state, HCl will not split as any ions. In gaseous state, HCl will not split as any ions. But when it comes to in aqueous state, when it's combined with the water, it will split as a H plus and Cl minus. So this migration of ions help the current pass through into the solution. So that's why now this HCl we can consider as electrolyte solution. Electrolyte solution. Instead of HCl, if you take cane sugar or alcohol, okay. Here if you take alcohol solution. Alcohol it do not split any ions. Alcohols it do not split any ions. That's why this is non-electrolyte. Why? The ions, the migrating ions are help the current pass through into the solution. There is no ions in alcohols and sugar. Okay. So which is undergoes the decomposition in aqueous solution, that all are electrolyte solutions. Okay. Which are do not undergo the decomposition in aqueous solution, that all are non-electrolyte solutions. Okay. Is it clear about the electrolyte solutions and non-electrolytes? Okay. Shall I remove this? Now we are explaining, we are discussing only almost these all are basics of electrochemistry. Why? Because electrochemistry is a somewhat difficult, not completely difficult. If you understand, very easy only. That's why I am explaining every term. Okay, I am going to remove this one. Next, next keep the heading electrochemical process. Electrochemical process. Electrochemical process is nothing but conversion of electric energy, conversion of electric energy 100 అన్ని స్క్రీన్ షాట్లు తీసుకో, నోట్స్ మాత్రం రాయకు. ఓకేనా? టేక్ ఇట్ స్క్రీన్ షాట్ ఫస్ట్. ఓకే. Conversion of electric energy to hello. Conversion of electric energy to chemical energy. Conversion of electric energy to chemical energy, or chemical energy to electric energy, or chemical energy to electric energy. Chemical energy to electric energy is known as electrochemical process. Electrochemical process. Okay. In this electrochemical process, we have to know about the cell. Conversion of electric energy to chemical or chemical energy to electric, that is called electrochemical process. Electro and chemical process. Okay. And now cell, the device where the electrochemical, the device where the electrochemical process, the device where the electrochemical process takes place is known as cell. Yes or no? ఇందాకనే చెప్పినా కదమ్మా, this is the device where the electrochemical process takes place is called, this is called cell, electrochemical cell. Now here, important point, if cell being used to convert electrical energy used to convert electrical energy into chemical energy energy. The cell is known as electrolytic cell. The cell is known as electrolytic cell. Being convert electric energy into chemical energy. That is called electrolytic cell. And one more, if chemical energy is if chemical energy is being converted into electrical energy the cell is known as electrochemical cell. This is electrolytic cell, which is calling electrolytic cell, convert electric energy into chemical energy. Electric energy into chemical energy is called electrolytic cell. And chemical energy, the conversion of chemical energy into electrical energy is called, the cell is known as electrochemical cell. This is electrolytic cell and this is electrochemical cell. Okay. Now we are going to discuss about the difference between electrolytic and electrochemical cell. Shall I remove this? Okay, I am removing this one. Shall I? This is first page. Electrolyte or non-electrolyte. And this is second page. And next page, the difference between electrolytic cell. Electrolytic cell and here electrochemical cell. Electrolytic cell and electrochemical cell. Okay, now here chemical change occurs due to flow of electricity. Chemical change occurs due to flow of electricity. Here Electricity flow due to chemical change. Electricity flow due to chemical change. తర్వాత వీటన్నిటి గురించి క్లియర్గా నేర్చుకుంటామమ్మా. అండ్ నెక్స్ట్ పాయింట్, electrical energy converted into chemical energy. Here electrical energy converted into chemical energy. Here chemical energy converted into electrical energy. Chemical energy converted into electrical energy. Polarity of anode is positive. Anode is positive, while that of cathode is negative. So in this opposite, polarity of cathode is positive, while that of anode is negative. Here ions discharged at deposited. Discharge is nothing but deposited. Ions discharged at both electrodes. Here ions are discharged only at cathode. And positive only at cathode. Okay, here this is important, amma. Polarity of anode for electrolytic cell is positive and cathode negative, and in electrochemical cell polarity of cathode is positive and anode is negative, and here ions are discharged at both electrodes. Discharging nothing but deposition. Okay, so deposited at both electrodes. అంటే యానోడ్ cathode కదమ్మా. యానోడ్ దగ్గరికి పాజిటివ్ నెగిటివ్ ions and cathode will get positive ions. Here ions are discharged at only cathode. Only negative ions are attracted towards the cathode. And next point, here both electrodes can be placed in the placed in the same chamber. Same chamber. Here, both electrodes both electrodes placed in both electrodes placed in different chamber. Different chamber. Copy this one. I will explain this with the diagram. Copy it fast. Electrolytic cell, electrochemical cell. Changing occurs due to flow of electrons. Electricity flow due to chemical change. Electrical energy converted into chemical energy, and here chemical energy converted into electrical energy. Polarity of anode is positive and cathode is negative. Here polarity of cathode is positive, anode is a negative. Ions discharged at both electrodes. Here ions discharged at only cathode. And both electrodes can be placed in the same chamber. Here both electrodes are placed in the different chambers. Okay, shall I remove this page? Everyone. Okay, right. Now I'm drawing this is a electrolytic cell here. And here this is electrolytic cell. And here this is electrochemical cell. Use scale. నాకు ఇక్కడ రావట్లేదు స్కేల్ లాగా. Here we have to take cathode and anode, right? Cathode and anode. Okay, here this is anode and this is cathode. Completely in this we have to take electrolytic solution. Electrolytic solution. And here complete this circuit. Here it is positive, anode is positive and cathode is negative. Okay, the electrons are moving from anode to cathode. Later I will explain about this mechanism also, how the electrolysis will happen. Okay, and here these both are electrodes. Use scale nana neat ga. These both are electrodes, but here this is anode only. Here also this is cathode. But when it comes to anode is nothing but here it is a negative charge. And cathode is positive charge. Cathode is positive charge. And this is the electrolyte. This is the electrolyte. And here the electrons are moving from same anode to cathode only. The electrons are moving from anode to cathode. And here these two are actually already we know that electrochemical processes occurs in the two electrodes are kept in different chambers. And ఇక్కడ ఒక divided ఉంటుందమ్మా. Different chambers. Okay. This we can call as partition, dividing. Tion, partition. Okay na? ఇది ఎలక్ట్రోలైటిక్ సెల్ కింద డ్రా చేసుకోండి. దిస్ ఈజ్ ఎలక్ట్రోలైటిక్ సెల్. Electrolytic cell. And this is electrochemical cell. Electrochemical cell. Electrolytic cell and electrochemical cell. Okay. Okay. This is the third page. Cypress one. And this is fourth page. Copy it fast, Amma. Okay, shall I remove this? The next electrolysis. Actually, up to now we discussed about what is the meaning of electrolytes, only all our definitions like right. Now electrolysis. What is the meaning of electrolysis? And strong electrolytes, weak electrolytes, non-electrolytes with examples. And what are the characteristics of anode and cathode? Okay. Okay, is it completed?